Okay, hello everyone. So the topic that we're going to study today is amines, which is the second last chapter in the NCRT, organic chemistry. Okay, so let us start. Basically, first we are starting by the structure of amines. So how do we get amines? So basically, amines are derived when we replace one hydrogen of ammonia by any alkyl or aryl group. For example, if we replace one hydrogen by CH3, we get an amine, right? Which is an alkyl amine. Okay. So let us see why are amines so useful? Why do we need to study them? Because they are used in medicine, like ephedrine, adrenaline, right? These medicines are used to treat BP problems. Then polymers, right? So you must have learned about polymers in your younger classes, like all these plastic bottles, nylon. These are all polymers, right? So fibers, as you can see it in the picture here, it is manufactured by making polymers which has amines, right? Okay. So that is its use in the daily life, right? And it is also used to make dyes, right? Like all the colors, right, which are used to dye clothes, right? These dyes, they are made by using amines. That is why it becomes very important for us to study it, as amines are involved in our day-to-day life, right? Okay. So how is the structure of amine? Let us understand. It is trivalent, means it makes three bonds. So it carries an unshared pair of electrons. Let us see. So I have nitrogen and it has, for example, three groups. It is making three bonds and there is an unshared pair of electrons. Now here the hybridization is sp3, right? The hybridization is sp3, but the shape is what? The shape is trigonal pyramidal over here, right? The geometry is sp3 and the shape is trigonal pyramidal. Why it is trigonal pyramidal? Because sp3 usually is tetrahedral, but because of the lone pair present on the top, the bond pairs, they shift to minimize the repulsion between this lone pair and bond pair. Okay, so the geometry is pyramidal, right? And so as I told you that the bonds shift, so the angle is less than 109.5, which is the tetrahedral angle, right? So it is 108 between the two CH3 groups. Now the angle is 108. It is reduced to minimize the repulsion between the lone pair and the bond pair. Okay. So now we are learning about the classification of amines, how we can classify amines. So you must have learned about primary carbon, secondary carbon, tertiary carbon. What is a primary amine? A primary amine is an amine where only one alkyl group is attached to the nitrogen, like how primary carbon it is. Only one carbon is attached to carbon, we call it a primary carbon, right? Here, two alkyl groups. Can you see two R groups here? They're attached to the nitrogen, so we call it secondary amine. In case of this, three alkyl groups are attached to nitrogen, so we call it a tertiary amine. Okay, so I hope you got the classification, which is very easy. Primary amine, secondary amine, tertiary amine. Because when we will be studying about the reactions, reaction mechanisms, so we will be, using these terms, primary amine, secondary amine, tertiary amine. So you should be able to picturize this in your mind, that what is a secondary amine, what is a tertiary amine, right? Okay, so in this video, we are going to study in very brief about the diazonium salt, right? And if you want to study in detail, we can, contact each other through the Ubuntu profile. So let us study what is diazonium salt. Okay. So diazonium salt, we have N2, we have nitrogen group along with the halogen, right? So how do we do the nomenclature? That is we have parent hydrocarbon plus diazonium plus the name of anion, right? So anion can be anything, but there is one diazonium group that is nothing but N2. For example, this. So here the hydrocarbon is what? It is benzene, right? So benzene, and we have here N2, that is diazonium, and we have chloride. Cl minus is called chloride. So the name becomes benzene diazonium chloride, right? Okay, now here in the next structure, we have benzene as the hydrocarbon, benzene diazonium. What is HSO4 minus? Hydrogen sulfate, right? So this is how we name the diazonium salt. But in NCRT for class 12 boards, we'll be working and doing reactions with the benzene diazonium chloride. Okay, now let us see. Okay, so these, basically these alkyl diazonium salts, they're highly unstable due to the presence of a positive and a negative charge. But these arene diazonium salt, which has a benzene, they are, they are stable at low temperature. The alkyl ones, they are not stable at all, but these are stable at low temperature. What is 273 to 278 Kelvin? That is 0 to 5 degrees Celsius. And even in laboratory, this is done, the reaction is done under cold conditions to prepare the benzene diazonium chloride. We take all the reactants, mix them, and we put it in an ice bath. Then only this reaction can happen, because low temperatures makes the reaction stable. Okay. And another thing is resonance. Due to benzene, there is a resonance, that is the positive charge is being delocalized, which brings certain stability, right? That is the reason arene diazonium is more stable than alkyl diazonium. See, resonance means stability. Resonance always brings stability. You can see the resonating structure here. Because of the resonating structure, the positive charge is delocalized in the entire ring, right? Hence, it brings certain stability, right? Okay. Now, let us move forward. What are the properties of diazonium salt? See, the diazonium salt, a colorless crystalline solid. And before that, let us study that, what is the reaction of, how do we make the diazonium salt? Firstly, we have amines, right? Amine, that is aniline. Aniline, we reacted with NaNO2 in the presence of HCl, right? And we get the benzene diazonium chloride, that is, we have the benzene ring, we have N2 plus and Cl minus, right? So this is the benzene diazonium chloride. What do we need? We need aniline, we need NaNO2, sodium nitrite, and HCl. And the temperature conditions should be very low, that is 273 to 278 Kelvin. What are the properties? Let us understand. It is a colorless crystalline solid. It is readily soluble in water. It is stable in cold water, because we know that, that benzene diazonium chloride is stable in, in cold water. So now this is divided into two categories. So there are reactions involving the displacement of the the N2 group, displacement means, removal. So where nitrogen gas is released, and reactions involving retention of the diazo group, that is the N2 group, right? Where N2 group is retained. Let us look at the reactions. So the reactions involving the displacement of the nitrogen. So these are the reactions. So basically, if I want to make, these are very, very important. So these are asked a lot in the board exams. How do we make? Basically in conversions. So for example, if I ask in the board exam that aniline, you need to convert aniline to chlorobenzene. Now, how do you convert aniline to chlorobenzene? The first step is you need to make a diazonium salt from aniline. How do you make a diazonium salt? You take aniline and you add NaNO2 in the presence of HCl. And again, the temperature should be very low, that is 273 to 278 Kelvin, right? And you get benzene diazonium chloride. Then if you add CuCl2 and HCl, now here the displacement of N2 groups takes place. It is removed entirely, it is removed. See, nitrogen gas is released. So if you add CuCl2, you get chlorobenzene in the presence of HCl. If you add Cu2Br2 in the presence of HBr, you get bromobenzene. If you get CuCN in the presence of KCN, if you add it to the benzene diazonium chloride, you are getting cyanobenzene. Now, these reactions are very important and it is asked in the conversions. Okay, so this method is not used to prepare iodobenzene and fluorobenzene, okay? Keep that in mind. Okay, now another is if you add copper in the presence of HCl, you get chlorobenzene. Copper in the presence of HBr, we get bromobenzene, nitrogen, and CuCl, salt, nitrogen gas, right? Okay, now reactions, other reactions, okay. So, right. Okay. So you can see here reactions involving the displacement of nitrogen. Again, we are forming iodobenzene by Ki, right? And HbF4. But we are not using it with acid in the presence of acid like CuCl2 in the presence of HCl. We cannot do Cu2I2 because Cu2I2 does not exist. Cu2 basically is a iodide of copper in the second oxidation state does not exist. That is the reason which we have studied in DNF block elements as well. Next is formation of fluorobenzene. Basically, you treat it with HbF4 and then it forms N2 plus BF4 minus and we get fluorobenzene, right? So again, these reactions are important. Okay, this is very, very important reaction. Both of these reactions, basically here, we are converting diazonium salt to benzene, right? Again, in the second reaction as well. So this is asked a lot in the board exam. When benzene diazonium chloride is treated with ethanol, what is the product you are getting? So we get benzene ring, right? We get benzene ring. We get an aldehyde, nitrogen gas is released and HCl is also released. But the main focus is benzene. So they ask us to convert aniline to benzene. What you can do, you can make aniline to benzene diazonium chloride. Then you can react it with ethanol and you form benzene, right? So this reaction is asked a lot in the exam. Next is hypophosphorus acid. So if you treat benzene diazonium chloride with H3PO2 and water, we get benzene, right? Again, please write and remember these reactions and practice them. Okay. Next, if I treat simply benzene diazonium chloride If you treat it simply with water, you get phenol, right? Now, these reactions are again the displacement of nitrogen, like N2 is removed entirely, right? This entire group is removed, right? Okay, this reaction is again very important. All of the reactions which involve the benzene diazonium chloride, they are very important. Okay. Next, okay. So this we have seen. If at the middle, in the, this reaction is used to form fluorobenzene, but at the mid, in the transition state, if we add copper and NaNO2, we are going to get nitrobenzene. Now, these are the second type of reactions that involve the retention of the diazo group. Means now the diazo group, the N2 group, is not removed, right? So here, see, we have the diazonium salt. So these are the formation of dyes. Suppose I have diazonium salt and I have phenol. This is phenol, right? So HCl is removed here, right? HCl is removed, right? And nitrogen triple bond gets converted to a double bond. This is called para-hydroxyazobenzene, right? So this reaction is, formation of dyes. So this produces an orange color dye. Okay. Next is, okay, so the mechanism is not so important. The mechanism will not be asked in the exam, but if you want to learn the mechanism, again, we can connect through Urban Pro. So let us see the next dye reaction, that is with aniline. This forms a yellow color dye. So if I have anilines, again, HCl is removed and we get a product where the triple bond gets converted to a double bond, right? Okay, so you can see here we get para-aminobenzene, which is a yellow color dye, and para-hydroxybenzene was a orange color dye, right? So these are the reactions involving the diazonium salt. So I hope you understood how we started the chapter with the very basics of amines, water amines, right? Water amines, and then we discussed about the diazonium salt. We discussed about the reactions of diazonium salt, two types of reactions, one with the displacement and other with the retention, right? So keep practicing. And if you have any doubts and if you want to practice more questions, study the chapter in detail, again, we can connect through Urban Pro, right? So thank you so much. Thank you for paying attention.